this video, we are going to explore what is meant by Friis Transmission Equation. This is one of the important factors when we are going to consider a two-antenna communication system. So this was first proposed by Harald T. Friis in the paper, a not on a simple transmission formula in the proceedings of IRE and waves and electrons in 1946. Consider a two antenna communication system. So this is the transmitting antenna, this is the receiving antenna, and they are separated by a distance of separation r. This distance r is such that it is greater than the far field distance. So both these antennas are located at their far field distance. So this Friis transmission equation gives an indication about the total received power in this antenna with respect to the transmitted power from the TX antenna. So this gives actually calculate what is the power received in this antenna when some power is transmitting from this antenna. So let's see uh, how it is. So calculating the Friis transmission, there are some of the assumptions taken. So first one is free space propagation. So it assumes that if we have this transmitting and receiving antenna, both are placed in free space. That is, there is no multipath environment between these antennas, such as there is no reflection, diffractions, or scattering from the environment. That is, there is no buildings, woods, nothing like that. So there is line of sight propagation between the transmitter and receiver antennas. And these antennas are aligned perfectly to have the maximum power transfer from the transmitter antenna to the receiver antenna. Next one is polarization match. So both these antennas have the same polarization. So we know that if there is polarization mismatch, there will be power loss. So in this consideration, we are considering both the antennas have uh, same polarization. And it is also assumed that there is no impedance mismatch. That means that whatever is power is fed to the antenna, it is completely received by this antenna. That means there is no impedance mismatch. Next is the far field condition. So the distance of separation between the transmitter and receiver is in far field zone. So these are some of the assumptions used for calculating the Friis transmission. So let's see how it is calculated. So now we have a two antenna system having distance of separations r between them. So this is the radiation pattern from the antenna. Based on the radiation pattern, it will be having different gains in different directions. So if PT is the transmitted power from this antenna, based on the gain of the antenna, total power transmitted from this antenna system will be PT, GT, theta T, phi T, where theta and phi t are the 3D angles of these patterns. So when we are considering the maximum power transfer, we know that this is the point. So it will be like PTGT. So this is the total power transmitted from the antenna. So when it is transmitted, it has to travel a distance of r. So when it is traveling a distance of r, there will be some power loss. So this power loss is indicated by this factor lambda by 4 pi r the whole square. So with respect to distance r, we can see that the total power will be getting reduced, because we can see that the power transmitted with respect to the distance is getting inversely proportional, so it is getting decreased. So this factor lambda by 4 pi r square is known as free space loss factor or free space path loss. So this is the loss given by the free space path between the transmitter and the receiver. So when this power reaches on the antenna, based on the antenna pattern of the receiver, it will be receiving some power. So this power will be PT GT lambda by 4 pi r square, which is received on the antenna, and multiplied by the gain of the receiver receiving antenna. So this is the total power inside which is received in this antenna. So this is the total power received by our receiver antenna, which depends upon the transmitted power, gain of the antenna, gain of the receiving antenna, and the free space path loss. So if we are considering both the antennas are arranged having the maximum power transfer, we can take GR as the maximum gain of the antenna of the transmitter, GR as the maximum gain of the receiver. So these equations will become GR lambda by 4 pi r square. So this equation gives an indication about the total received power in the receiving antenna with respect to the transmitted power. So this equation has lots of importance in considering the two-way antenna communication. So this forms the basis of link budget calculations. We can see what is meant by link budget in our upcoming videos. So if you find any of our videos useful, kindly support by liking, commenting, sharing and subscribing. Thank you.